Hello and welcome back to SciTech. In this video, I'm going to show you how to make a very simple blinking LED circuit with using a PC817 OptoCoupler and a few other simple components. Let's get started. And these are the items that you're going to need to make for this project. The items you're going to need is a 3-volt button cell battery, 3-volt button cell battery holder, an LED color of choice, I chose red, a 220 microfarad electrolytic capacitor, a 6.2 k ohm resistor, a 1 k ohm resistor, and a PC817 OptoCoupler. Now, let's go ahead and assemble this project, and let's get started. Now you may be asking, what is an optocoupler? Basically, an optocoupler is a circuit that is not electrically connected. And as you can see, you have an LED and a transistor. More accurately, a phototransistor. And this phototransistor is a switch that is not electrically connected either, where this part here is the collector, and this part here is the emitter, and this part here is the base. The base will be like the button of the switch, and it will only be activated until the LED turns on when the LED receives an input voltage. When the input voltage passes through and turns on the LED, it will electrically close the switch, which will then cause the collector to send a signal over to the emitter, which will then allow the transistor to function. Basically, that's how an optocoupler works. If you want to see a visual, basically it is very similar to, say, an LED and this phototransistor, or this LDR. You have the LED that will turn on, and will turn on this little LDR. LED goes in, and it allows these two parts to connect. Exactly the same way as, for example, a transformer, how a transformer functions. If you look at the two coils right here, you have the primary coil and then the secondary coil. The primary coil has the input voltage. In this case, it's 120 volts AC. And as you can see, they're two coils of wire, not electrically connected. They are connected between this iron core, which creates an electromagnetic field, which then creates a current through the secondary coil, which then allows an output voltage to be released. So basically the same way as an optocoupler would work. Input voltage generates electromagnetic field, goes to the secondary coil, which receives the electromagnetic field, and it creates an alternating current voltage of, say, 12 volts or 24 volts. In this case, it's 1,500 volts for a microwave transformer. Of course, every transformer is different. So there. And there, now you know how a basic optocoupler works. And this right here is the schematic that you're going to need to follow to make this circuit. First, I'm going to take the optocoupler and some flush cutters and shorten the leads. And there we go, it should look just like this. Next, solder tin all the leads that is on the optocoupler. And there we go, it should look just like this. Next, I'm going to take the 1 k ohm resistor and place it right here next to the optocoupler, next to pin 2 and 3. What I need to do is shorten the leads, modify them so that way they can be closer to the optocoupler. There we go, perfect size. Soldered in the leads. Next, solder the 1 k ohm resistor to pin 2 and 3 to the optocoupler. And there we go, soldered into place, and now cut off the excess. Next, take the 220 microfarad electrolytic capacitor. This pin right here is the negative, and I'm going to go and bend over the lead. Solder tin the negative, and solder tin the positive. Next, solder in the positive pin of the electrolytic capacitor over to pin 3 of the optocoupler. And then solder in the negative pin of the electrolytic capacitor to pin 1 of the optocoupler. Next, I want to connect the LED to the circuit. This pin here is the cathode, and this pin here is the anode. And I want to make sure that I connect the cathode of the LED to pin 4 of the optocoupler and the anode free for now. Take the leads of the LED, bend it over, spread out the leads open like this. And now take the cathode and place it right over here next to pin 4. Next, solder tin the cathode of the LED, and then solder it to pin 4. Cut off the excess. Next, I'm going to solder tin the lead of the 6.2 k ohm resistor. Cut off the excess. And then solder tin the other end of the resistor. Next, take the 6.2 k ohm resistor and solder it to pin 1 of the optocoupler. And now go and move the 6.2 k ohm resistor, bring it over to the anode of the LED, and then solder it to the anode of the LED. Next, I'm going to take the 3-volt button cell battery holder and attach it to the circuit. Solder tin the leads. Next, take the negative terminal of the 3-volt button cell battery holder and connect it to pin 2 of the optocoupler. Solder it into place, and there, pin 2 is now grounded. Next, I'm going to take this wire and solder it to the anode of the LED. And then take the other end of the wire and solder it to the positive terminal of the 3-volt button cell battery holder. And there, the circuit is now complete. Now let's go ahead and test it out. Take the 3-volt button cell battery, plug it in, and there, as you can see, the LED is now blinking. And there, the project is now complete. Let's see how this looks in the dark. Plug in the 3-volt button cell battery. And there, as you can see, the LED is now blinking. And there, that looks very nice. And there you have it. Now you know how to make your very own blinking LED with using an optocoupler and a few other simple components. Thank you for watching SciTi Tech. I hope you learned something new, and don't forget to like, subscribe, and of course click on the bell icon to be notified for future SciTi Tech videos. Till the next tech, goodbye.